Understanding work done on a constant force. This is the graph. This is the figures that we're using for part A through part D. Which of the following statement accurately describes the sign of the work done on the box by the force of push? The force of push we'll be looking for is Fp. Fp will be represented for force push. Fp. Force of the push. In our graph, Fp will be on the right, meaning that it will be positive of the x-axis. Part B, which of the following statement accurately describes the sign of normal force? Normal force will be N, and we're looking for N. N will be in the middle of the x-axis, which not moving anywhere, which will be 0. Which of the following statement accurately describes the sign of work done on the box of the force of kinetic friction? Kinetic friction will be represented for Fk. 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 Friction kinetic, which would be negative because it's be on the left of the x-axis. So left, negative. Part D. Which of the following statement accurately describes the sign of work done on the box of the force of gravity? Gravity is represent G, and G will be the gravity will mostly take part of weight, and W is close to that similarly because it'd be facing downward, and gravity is pulling downward, so it will be W, and W it's not showing, it's not moving, so it'll be 0. Just moving on a new apartment and trying to arrange your bedroom. You would like to move your dresser in that weight of 3,500 newtons across a carpet spot of 5 meters away on the opposite wall. Hoping just to slide your dresser easily across the floor, you do not empty your clothes out of the dresser, the drawer. Before trying to move it, you push all your might, but you cannot move the dresser before becoming completely exhausted. How much work you do on the dresser? 0. Because there's no friction, there's no movements. There's no movements, meaning there's no work. To that dresser. To that dresser. Part B. A box of mass of m is sliding down a frictionless plane that's inclined the angle of theta above the horizontal as shown in the figure. What is the work done on the box by the force due to gravity of W if the box moved in a distance of d? Here's d, and we're looking for the distance, or we're looking for the work done by gravity. And since that's taking place, it'll be gravity. It'll be part of it. Gravity force times the displacement of the figure times the cosine of the angle between gravity, between the force and the displacement, which will give us the weight of it. And to give us the weight will be giving us the equation. 90 will be the angle of it with theta, and that's how you find the work done by this force. The planets traveling approximately the circular orbit at a constant speed around the sun What's the network done on the gravity by the gravitation between it and the sun in complete orbit, absorbing that the mass of Earth is given of me and the mass of the sun is given for ms. Ms of the sun, the distance is given by the re. Knowing that, we'll be looking for a workforce. Well, they give us a workforce and the distance where the force is directly in the movement. But in this case, the force is at a right angle movements, going to the right. But it's not showing any work. Not showing any work because of the sun. That means it's 0 because the sun is in place while the Earth is orbiting in a constant speed around it. A block of mass is m is pushing against the spring, and the spring at a constant k until the spring has been compressed, and a distance x from an equality. What is the work done on the block by the spring? The question is, however, asking us how much work spring did on the block since the block is performing a positive amount of work. The work is done by a spring placement and displacement x from an equality. It's always 1/2. 1/2 of kx equals squared. Always that. The spring does a negative because it's up against the block is up against the spring and keeping a constant movement of the spring. Since the work of 1/2 k is x squared in the block, it would be none of these choices. Showing that the work is done by the block of the spring.